Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. So today in this lesson, we are going to attempt some of the questions from chemical energetics. So this is the question from May-June 2024, variant is 21. So the question is the equation for the complete combustion of ethine is shown. So this is the reaction which is given to us, and this reaction is basically the exothermic reaction. Explain using the idea about bond breaking and bond making why this reaction is exothermic. Always remember, you have to remember one thing, that the bond making is exothermic. We can write here, bond making is exothermic, in which heat is released, and breaking is endothermic. What does it mean? It means when bonds form, then heat energy is being released to the surrounding. So we will see energy released in bond making, and in bonds breaking, energy absorbed. In bond breaking, energy absorbed. So first point we have written, bond making is exothermic and bond breaking is endothermic. So the second point I will write here, that in exothermic reactions, more energy released in bonds formation than energy absorbed in bonds breaking. So always remember one thing, that bond making is exothermic process and bond breaking is endothermic process. If more energy is released to the surrounding, then we will say that the reaction is exothermic reaction. So for exothermic reaction, we have to label this diagram. We have to label the reactants, products, enthalpy change of reaction, and activation energy for this exothermic reaction. So we are going to draw it now. Reactants will be here, this one. So all of you must be very much careful about the arrowheads, direction of arrowheads. Here you can see this is the direction of arrowhead, and this is the activation energy. And now we have to label the reactants and products. So here these are the reactants, C2H2 plus 5O2, and where are the products are 4CO2 plus 2H2O. So these are the products, and these are the reactants. So next we have to enthalpy change. We have to draw the enthalpy change. For enthalpy change, we will place it here. Energy is released to the surrounding. For exothermic reactions, the enthalpy change will always be negative. So this is the enthalpy change for the reaction which is given here, we have drawn here. So it will be the negative one, because it is for the exothermic reaction, for the energy profile diagram for the exothermic reaction. So I am going to give you some more understanding about the endothermic reaction as well. If we have to draw the structure of endothermic reaction, in that case, what will be the difference between them? In endothermic reactions, product have more energy than reactants. So if we are going to place it a little bit down, it will be good enough for us. Okay, here is the energy, and this one is the progress of reaction. progress of reaction. Here are the reactants and here are the products. So next, activation energy. This one is the activation energy, and whereas both arrowheads will be towards the upward side, so this one is the enthalpy change. And for the endothermic reactions, this is the energy profile diagram for the endothermic reaction. And endo means in and therm means heat. Endo means in and therm means heat. Endothermic reactions are those reactions in which heat is taken in from the surrounding, are called as the endothermic reactions. So this is a similar question from the variant 2 May June 24 5070. So this is the similar, this is a question which you will attempt in a similar way. This is the reaction which is an exothermic reaction. For exothermic reactions, you have to again define it and try to attempt it by yourself. This is your time to attempt this question. Draw the energy profile diagram for the exothermic reaction, in which will be like this. Okay, you will write here reactants that are CH4 plus O2, and here will be product. Always remember, in exothermic reactions, products have less energy than reactants. This one is the activation energy, and another will be this one with the enthalpy change of reactant. Okay, this one always be negative for it. Now, this is a question from October-November 2023. Variant is 2.2. Steam reacts with carbon to produce carbon monoxide and hydrogen. The forward reaction is endothermic reaction. So here we are talking about the forward reaction is the endothermic reaction. So explain in terms of bond making and bond breaking why this reaction is endothermic. So this reaction is very much important. And so you have to memorize and write the two of the points and explain these questions very well. First of all, we have to write the answer like this, that in endothermic reaction, first of all, we will tell that the endothermic is also bond breaking. Let me write. Bonds breaking is endothermic, and bond making is exothermic. So in endothermic reaction, more energy is absorbed in bonds breaking than released in bonds making. Then released in bond making. So this will be the reverse of exothermic reaction which we have done right now. So we are going to talk about the bond breaking and bond making. The transfer of thermal energy in a chemical reaction called the enthalpy change. Okay, write the symbol for the enthalpy change like this. Include the sign for an endothermic enthalpy change, it will be positive. For endothermic reaction, enthalpy change is positive, whereas for exothermic reaction, the enthalpy change is negative. This is the question from specimen paper 2023. The question is basically just similar to the previous one. For this, you have to draw the exothermic energy profile diagram for exothermic reactions. So if we are going to draw it like this, I have to write reactants at one side. All of the reactants we can write here, all the reactants here, okay? And we can write this product here. This one is CH3, C double O, CH double bond CH2 plus H2O. So how we are going to draw it? We are going to make the energy activation. We have to label this X's. This one is the energy. And then the reactants and products, the activation energy and enthalpy change. So this one is the activation energy. And this one is the enthalpy change. It will be delta H. This reaction we have done. So for exothermic reactions, you will attempt this question here, okay? So this is a question based on the calculations of bond energy and bond making. We are going to deduce either the reaction is exothermic or endothermic. So we have to follow the instructions of this question. The symbol equation for the reaction can be represented as shown. So this is the reaction. Bonds energies are given for NN and HH. Use the bond energies in table 3.1 and delta H to calculate the bond energy of a NH bond. NH bond in kilojoule per mole. So calculate the energy needed to break bonds in the reactant. So we have to calculate the energies. So for this, what we are having, if we are going to calculate the bond energy of N triple bond N are given to us, that is the bond energy is 945, only 1 mole of it there. So 3 moles of H2, so there are 3 H2 moles are there, plus 3 H bonds are there. So we will multiply 3 by energy of HH is given, that is 435. Let me calculate it. 945 plus 3 into 435. Answer is 2250. You have to remember one thing here, that on the reactant side all the bonds are broken. So when bonds are broken, energy is being absorbed. So when energy absorbed, we will use the sign plus. So this amount of energy, 2250, will be absorbed here. So we will get the value plus 2250. So calculate the energy released when bonds form in the product. So we have to calculate the energy released. For this, we must know the bond enthalpy of NH bond. If we can see what kind of calculate the energy released when bonds form. So for this, we will put the formula here. Delta H is equal to H1 plus H2. So if we are going to consider the heat energy of reactant is H1 and for product is H2. So there are so many NH bonds, 1 NH, 2, 3. Okay, there are 6 NH bonds which are formed, but we do not have energy here. We have the value of delta H, that is minus 90 given here. Delta H value is given here, minus 90. And H1, this is if we are considering H1 for the heat energy of reactants are plus 2250 plus H2. This one is the amount which we have to calculate. So if we have to calculate the value of H2, we will move it here. So by adding these values, plus 2250 plus 90, we can calculate the value of H2, that is the bond energy of NH, and the answer is 2340. So here we will write the answer 2340. Calculate the energy of NH bond. So if we are talking about this part, this is the value which we have calculated of 6 NH bond. 1, 2, 3, 4, 5 and 6. There are total 6 NH bonds which are having the value 2340. NH, one single bond is there between them. So if we will divide, if we want to calculate the bond energy of NH, we have to divide this value by 6 and answer will be 390. So 390 kilojoule per mole is the answer for this reaction. So you all have to calculate the bond energies accordingly.